Hello, Mr. Melo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular looking at how you can solve triangles with the law of sines. So if you find this video helpful, consider hitting the like button, subscribe, and let's go. Now, law of sines, what is it first? Just as a quick recall, and it says the following. If you have a triangle ABC where I have labeled the angles with capital letters and their opposite side lengths with the lowercase letter for that angle, I will have that the ratios of sine of the angle and its opposite side length will always be equal. So sine of angle A divided by its opposite side length A should be equal to sine of angle B divided by its opposite side length, or sine of angle C divided by its opposite side length. That's all it says. So without further ado, let's look at how we can use it to solve some triangles. So the first types of triangles I want to look at are either AAS or ASA triangles. So here I'm given one side length and two angles. In this case, I'm given side length A, angles A, and angle C. I always start by having my students draw a triangle and label what they know. I don't require this to be to scale. I think this is just to get your bearings on what you know and what you don't know. So I've drawn my triangle ABC, and now I label what I do know. So here's what I have. Now, if you're in either of these cases, an AAS or an ASA, you should always recognize whenever you know two of the three angles in a triangle, you can find the third angle by subtracting the two that you do know from 180, because you know the angles in a triangle need to add up to 180. So the first thing I would do in one of these triangles is, if I know two angles, solve for the third. So angle B is going to be equal to 180 degrees minus the sum of the two angles I do know. So I see that here I have angle B is 39 degrees. I'll go back over and label my 39 degrees in my triangle here. So this is what I start with. Now, to continue solving with the law of sines, and the reason you know it's a law of sines problem is whenever you can pair up an angle and its opposite side length in these types of problems, you're going to be able to apply the law of sines. So what I do is I know I have angle A and side length A, so an angle on its opposite side. So I can start by writing sine of angle A, that 98.2 degrees, divided by opposite side length A, 13.35 degrees. And that should be equal to any one of the other ratios. Now, you can solve for side length B or side length C first. Does not matter which one we solve for. I tend to tell my students solve for the small angle just because small side length, because it does matter which angle you would solve for. But it doesn't matter here, but just because with the law of sines and you're solving for angles, you always solve for the small angle first. Just to make it easy, I always just say solve for the small side or the small angle first. So you're always thinking small with sine. So in this case, that means I, in particular, would end up solving for side length B because angle B is smaller than angle C. So I'm going to do sine of angle B, that 39 degrees we just found, and divide it by side length B. I can rearrange to solve for B, so isolate it to give me B is equal to 13.35 sine of 39 degrees, all divided by sine of 98.2. You can plug this into your calculator to approximate it to get a side length of about 8.488. So I will write that in for B over here, 8.488. And then I just need to do the same thing to solve for angle C. And I like to start with the angle and the opposite side length I knew before. That way I'm not using any rounded values. So again, I'm going to start by writing sine of 98.2 degrees divided by 13.35 because it's exact. I have not rounded anything. I will set that equal to sine of angle C, so 42.8 degrees divided by opposite side length C. Now, you could use angle B and its opposite side length, but because I rounded side length B, I just tried to not use it because, again, exact stuff is always better to use. So now, if you want to solve for side length C, you need to rearrange this to isolate it. I could cross multiply and divide to isolate C to give me 13.35 sine of 42.8 degrees, all divided by sine of 98.2 degrees. You can plug this into your calculator to get that side length C is about 9.164. So about 9.164. And now you've solved your entire triangle. So any AAS or ASA triangle is going to look similar to what we just did here. Now, the second type of problem you will use with the law of sines or triangle you'll solve is an SSA triangle. So this is called the ambiguous case because it is a pain in the you-know-what. So, but I'm PG here, so SSA. So, there's three different possibilities here. You could have a no solution triangle, you could have a one solution triangle, or your triangle might have two possible solutions. So let's see how I have my students determine how many solutions they're going to have and find what the solutions are. So, again, all my problems, I have them start by trying to draw some sort of triangle, not to scale, to orient them to what they know and what they don't. So here's my picture not drawn to scale, and I've labeled it in orange what I do know. Now, there are some teachers and textbooks that tell you memorize a bunch of formulas and then you can decide what situation you're in. That is not really going to be that useful. I suck at memorization. I would guess a lot of your students do too and don't want to memorize all these cases. So here's how I decide that this really is no solution. Whenever you have a law of sines problem, you know you start off with an angle and its opposite side length, you know. Here, I have angle C and side length C. So if I'm just going to go about trying to solve this with the law of sines, I would write sine of angle C, so 22.3 degrees, divided by side length C, so 0.3. And with law of sines problems, you always try to then solve for an angle or side length next. In this case, the only other value of information I have is side length A, so I have to be solving for angle A here. I don't have anything related to B's yet. So I'll have sine of angle A divided by side length A, which means I have to be trying to solve for angle A here. So I'll isolate sine of A to give me sine of angle A is equal to 22.sine of 22.3 degrees divided by 0.3. And then I'm going to apply sine inverse to both sides. So when I go to plug the right-hand side of this equality into my calculator, I get an error. And that is because the inside here, that 2.2 sine of 22.3 degrees divided by 0.3, that is too large. It's greater than 1 in this case. So it's not defined. Since my calculator is spitting an error message back at me, this is a way for me to know I'm in the no solution case of the law of sines. So I have no solution. And that makes me happy because I'm done doing work here. So this is pretty much going to give you every time you have no solution. There might be a small other instance, but this is pretty much it. So no solution. Look for something absurd, either a calculator or something else that doesn't make sense to you, and you'll find it. If I'm going to look for the one solution case, I'm going to expect I won't have a calculator error at first. So I start off exactly like before, get my bearings, draw my picture and label, and I do that here. Then I need to set up the law of sines. So my opposite angle and side length that I know is B. So I can start by writing sine of 30 degrees divided by side length B is 21.45. The only other information I know is about side length A. So I'm going to set this equal to sine of angle A divided by that side length A of 42.9. And now I'm going to isolate sine of A and then solve for angle A just like before. So I do this here and get that angle A is actually 90 degrees. So I'll put 90 over here. And in this case, I could actually just start using my right triangle trick here. The second you have a 90 show up, you know it's a right triangle. So I could do that. But for the sake of argument, I could go in and solve for angle C next with the law of sines. So I would again start with our angle C by knowing my other two angles first. So my three angles need to add up to 180. So 180 minus 30 minus 90 is going to tell me 60 is equal to angle C. So that's angle C. So I can write my 60 up here. Then side length C, I could use right triangle trig. I could use special right triangles because I know this is a 3069 triangle now. But I could also use law of sines if I didn't have a special case like that to get side length C is about 37.152. So this is my only solution in this case. But how would I know this is my only solution? So this is first solution. Well, whenever you have a right triangle, you know it's going to be the only solution. But you don't have to have a special case memorized like that. Because whenever you have your first solution, you should test to see if there's a second solution. If there's a second solution, you're going to look to that very first angle you found here. So in this case, the first angle we found was A. So if there's going to be a second solution, your new angle A in this second solution is going to be equal to 180 degrees minus the old angle A. So in this case, I have 180 minus old angle A was 90. I just have 90 degrees. This is the same as old angle A. So I don't have a different angle here. So it's actually just one solution. So one solution since new angle A is equal to old angle A. The other scenario where you might have that there's one solution, maybe you end up with a value that reads something along the lines of the following. So maybe you do 180 minus that old angle A to get a new angle A of, say, 155 degrees. So this doesn't match our numbers here. But you would look to say, well, this new angle A, can it coexist or not coexist with the given angle? So angle B. If I had the B of 30 here, I would say, well, I cannot have an angle of 155 and an angle of 30 degrees in a triangle because this would add up to 185 degrees. That would be too much. I'd have too much angle. So I would know there wouldn't be a second solution. So you'll either have you'll know you're in one solution by either getting the same angle back, so 90, or you'll get out a value that's too large to possibly be an angle in our triangle. So this is what you'll have in the one solution case. The two solution scenario, so that third version, is what you will have when you run through your first solution argument. So I saw my first solution just like before, but then when I go to check for my second solution, I say, well, the first angle I solved for before was angle C here with a 32.611 degree angle. So I'll say new angle C is equal to 180 degrees minus old angle C. And it really has to do with how our inverse functions are constructed and why you have these possibilities. In this case, I have a new angle C of 147.389, and because my new angle and my given angle are small enough so they add up to something less than 180 degrees, my angle's not too big and I can have a second solution. So my new angle C and my second solution is this 147 and change here. I have my given angle A from the original statement of the problem. My new angle B is just going to be equal to 180 degrees minus the two other angles in my triangle. So minus our given angle of 23 and our new angle C of 147.389. So that will give you an angle of about 9.611 degrees. And then finally, you could solve for your side length b. So I set up law of sines. Again, still using the information I knew from the beginning because these aren't rounded, to give me a new side length b of about 2.478. So here's an honest to God 2 solution example. So I know this video is longer than the usual ones. I hope you found it helpful, but these are the only types of law of sines problems you'll get. So if you found the video helpful, hit the like button and have an awesome day.